Amazing story that only broke yesterday, and Terry's going to kick off with this one. This is water on the moon. Terry, take it away.
Yeah, you can have water in lots of places. It seems actually, seriously, there's water all over the solar system and indeed right throughout the universe. But when I was starting off in astronomy, the moon was described as totally barren, totally dry, no atmosphere, absolutely lifeless. We now know that it has occasionally got a very, very thin, tenuous atmosphere, temporary. And we now know that there is water on the moon. We've known for quite a while that there's water in the form of ice near the poles of the moon in craters that are permanently shadowed from sunlight. So they never get the sun shining on them, no matter what way the moon is pointing. And any ice that's there never gets hot enough to melt. That's fine in so far as it's something there. It's in very remote, inaccessible parts of the moon and very, very little of it. But there was a lot of talk whenever we were thinking about setting up bases on the moon, that would be the only place to have the bases, because you do need water. It's very, very expensive to get large quantities of water sent all the way to the moon for a base that's going to be permanently crewed. Well, the latest finding now is that there's also water on the side of the moon that does get sunlit, and more importantly is facing towards the Earth. And that makes it an awful lot easier for communication. So the latest story now is that SOFIA, the Stratospheric Observatory for Infrared Astronomy, which is an amazing telescope, 106-inch diameter telescope, mounted in a specially modified Boeing 747 airliner, flies up to 45,000 feet. And this amazing telescope inside the body of the aircraft looks out through a special screen and can observe the sky. What's the point of that, you may ask? It's because at that altitude, it's above 99% of the water vapor in the Earth's atmosphere. And for looking for water vapor in other parts of the solar system, you obviously want to get above as much as possible of the water that we have here in our own atmosphere. So they used a special instrument called Forecast, which is the faint object infrared camera from the SKA Telescope, backed up by information from a spacecraft orbiting the moon called Lunar Reconnaissance Orbiter, and they detected water. I'll say a wee bit more about what form it's inside the gigantic crater Clavius, which you can see tonight. I'll say more about that in the last section. So they discovered a definite spectral signature of water, not just hydroxyl, which would be a mixture of hydrogen and oxygen, but not water. That had already been detected, but this new signal, they say, is unambiguously that of water, in the form of water molecules, which could either be embedded in little glass beads that have been formed by meteorite impacts, or possibly, and this would be even better, buried in little sort of interstices, I think I've got that right, in the lunar soil a bit below the surface. We don't know how much there is in terms of depth, but from what they measure, it's round about 100 to 410 parts per million of the lunar regolith, the lunar soil. That doesn't seem very much, but it's roughly equivalent to a small bottle of water per cubic meter of soil. And that's not bad. Now, the question is, how do you get it out? If it's in these little glass beads, you obviously have to process them in some way. If it's in the little micropores between the lunar soil particles, it'd be a lot easier to extract and use. And of course, water is essential not only for any sort of a base that's going to be permanently crewed, but you can also break it down. And that gives you hydrogen, which you can use as a fuel for launching a rocket off, say, from the moon towards Mars. And it gives you oxygen, which is essential for breathing. So large quantities or sufficient quantities of water are absolutely essential. There's definitely ice at the poles that, as I say, we know probably fairly large quantities. The trouble about that is that because they're at the poles, they're just on the limit of what can be communicated with regularly from Earth. The moon rocks backwards and forwards on its axis for reasons which we didn't go into here, by almost up to 8 degrees. And that means there would be times when, say, your antenna on the rim of a crater at the moon might be temporarily blocked from communicating from Earth. Now, some of the stories that you hear talk about the dark side of the moon. There's no such thing as the dark side of the moon. The moon gets 14 days of daylight and 14 days of sunlight, which add up to a month, all over the surface, again, ignoring any craters that are deep enough at the poles to not get the sunlight. So while the surface of the moon pointing towards us, including the crater Gravius, is always pointing towards the moon, it also will get 14 days of night as well as 14 days of sunlight. So any base there is going to go through the whole cycle of a lunar day, 14 days daylight, 14 days night. And during the day, it gets very, very hot. During the night, it gets very, very cold. Some of the ideas for a lunar base indicate that think that it might be best to use things called lava tubes, which are underground tunnels basically caused by molten lava. I don't think there are any discovered so far anywhere near Clavius, but nevertheless, that'll sort of renew the interest for looking in that area. But if there's water in the Clavius area, there may well be water in other parts of the moon, including some that are near these lava tubes where it might be possible to set up a base. So it's very, very interesting. We'll be talking later on about whether these discoveries, exciting discoveries, are always accurate the first time around. We'll be talking about Venus in a moment. But the main thing about this is that it's an indication that water is quite common right throughout the solar system. We're not sure yet where this water might have come from, probably deposited there by meteorites or comet fragments, or possibly by chemical interactions, because the moon is constantly bombarded by very energetic particles from the sun, and there are possible reactions which could take place between those energetic particles and other chemicals on the moon, which give you oxygen, or sorry, give you hydrogen and oxygen, and therefore water as an end product. So very interesting, very promising, and we'll look forward to further information on that. Nick, I'm sure you have thoughts on the matter as well.
It is fascinating. I mean, this result, it was interesting that they announced it as a new result. This data was actually some years ago now. So the Sophia aircraft, as Terry was saying, it's a modified 747 SP. I was fortunate enough to go on it some years ago down at the DLR Center, Deutschluft Center, which are one of the partners in the Sophia aircraft over in Germany. And it is remarkable. As Terry was saying, you've got this 2.5 meter wide telescope that's basically got to survive being on a 747. So any of the astronomers in the audience will know that this is a big problem. You put a telescope out in a field and a bit of wind is going to make it flutter, unless you've got a really good strong mount. Now imagine putting basically a 1 ton, 2.5 meter wide telescope on the outside open side of a 747, traveling at 800 kilometers an hour. And you've got all the wind shear issues to deal with, the fact that the telescope only moves in kind of altitude rather than azimuth, so it can only really move in that direction. So the pilots have got to be incredible in terms of keeping it locked on. The thing is with the moon observations as well, they had no star to lock onto. They were doing something quite radical for the Sophia project. The observations were taken in August 2018 in a period of just 20 minutes, and the data reduction for that, the process data that came back 6 months later. But it is quite an amazing result. But this telescope, going back to it, the bearings on it that make it move are kind of polished down to 10 microns, so 10/1 millionths of a meter. It's just, it is an astonishing instrument, this remarkable 747. In terms of how it got there, the water, well, the moon has been bombarded all through its history. The late heavy bombardment around about 4 billion years ago, which peppered the Earth and the inner solar system, gave us a lot of the craters that we now see on the moon. That's one potential, as Terry was saying, lots and lots of both cometary and meteorite impacts. We know that comets are laden with water. So that could have been one of the reasons that this water was dumped there. The LRO, the Lunar Reconnaissance Orbiter results as well, are really interesting because they found it in these, what they call cold spots, these kind of shadowed regions, literally dotted all over the moon. A lot of the news reports were kind of intimating it was going to make it much easier for bases. It's not. It's going to be incredibly difficult to get this out. So fans of Arthur C. Clarke, 2001, Clavius base. This is, most of the detection was in the Clavius crater, which is a beautiful crater, by the way. As Terry said, we're going to talk about that. If you remember 2001, that's where the big lunar base was. It may happen, it may not, but it's still fascinating, and it's just wonderful again to see a big science story make major news headlines. So it's one that's going to evolve. We'll kind of watch this space and see where it leads us, really. So great story.
Yep.
Love this one. Loved it. On to our next story, slightly closer to home. So how do we begin with this one? Right. So the UK has a plan to become a launch site for space rockets. So this is a government directive that's been ongoing for some years now, and there's been all sorts of debates and discussions and surveys as to where we're going to be the best sites. Now, Scotland seems to be the preferred option for many of the sites. There's one site proposed in Newquay in the Cornish coast. That's going to be going with Virgin Orbit, using, again, a modified 747, which is going to basically be dropping rockets off the side wing of 747 and then going into orbit. That's pretty well developed so far. They're developing what's called a TGOS, a fueling system for that right now. So really good plans for that one. The sites up in Scotland are developing at varying different paces. So you've got one at the Western Isles, you've got one in Sutherland, which was up until this week the preferred option site. So the UK Space Agency and a company called Lockheed Martin, who are one of the big US defense primes, and another company, Danish company called Orbex, were kind of collaborating, and a lot of money been pumped into this site at Sutherland. Now, there are all sorts of objections to the site at Sutherland. One was that it's a SSSI site of special scientific interest. So there were lots of objections from that perspective, from an environmental point of view, but the team that have been working are doing a lot of due diligence in terms of the environmental side. However, it is a peat bog. Basically, the entire area is covered in peat. Now, peat, when it dries, is incredibly flammable. So possibly not the most optimal site from that respect, but still it was progressing quite nicely. The other issue that they had was one of range trajectory safety. So my company and various other companies have been doing lots of analysis on this, and there's all sorts of issues because these rockets aren't going to be like launches from Cape Canaveral or Kourou. So the reason why Cape Canaveral and Kourou are commonly used is they can easily put rockets into what's called an equatorial orbit. So they're the ones that you typically see spinning around, like the International Space Station goes around the Earth in kind of this equatorial region area, goes up and down a little bit, and basically that's ideal for those. The rockets being launched from Scotland don't really go into those kind of orbits. They're more optimized for what's called polar or sun-synchronous orbit. So polar orbit, basically what happens is the Earth's rotating and the rocket's going over the poles. And as the Earth's rotating below it, you get different stripes. So they're great for observational, for Earth observation science, that type of thing, for military and defense purposes. Ideal if you want to basically look at certain countries and certain nations. Sun-synchronous, very similar orbit, but essentially you're always in sunlight. So great from a power perspective. The issue with the Sutherland site is that the launch range trajectory for it was basically going over the North Sea oil fields. So in terms of range safety, there are all sorts of issues with potential aircraft flights. The aircraft coming in from transatlantic flights typically fly over that part of Scotland and then down towards Heathrow. So that was one of the issues. The other issue is large amounts of fishing vessels in the area, the oil rigs, and then the Faroe Islands as well. So all of these were potential problems for the site. What LM seem to have now done, and there were lots of discussions about it in my office and various other engineering kind of companies in the space sector who were looking at what could happen, is that they appear to have gone with what I would say and what many would say is the better option in terms of launch range trajectory, and that's Shetland. So Shetland site, again, it's polar sun-synchronous orbits, but the trajectory means that essentially it's not going to have this problem with the oil fields and the Faroe Islands. It's got lots of other advantages as well. It doesn't have to do what's called a dogleg maneuver. So essentially, to avoid some of the stuff, it's got to kind of do this maneuver on launch, and essentially what that means is you're going to be able to put bigger payloads, potentially bigger rockets, and the launch cadence, the number of launches per year that they're planning from Shetland, is higher. So with Sutherland, they were kind of limited due to some of the environmental concerns and what they'd already stated to approximately 12 launches a year is what they're aiming for. With the Shetland site, they're aiming for potentially up to 30 launches a year, which therefore makes it a lot more economically viable. There's also military defense range trajectory sites up there. There's a company called Kinetic who run radar tracking and various other kind of observational facilities up there. So it does seem to be a really smart move on the part of LM to do this. The question is, though, a lot of the money funding this came from the UK government, UK Space Agency, and was pumped into initially the Sutherland site. So it's one of these stories that's, I think, going to evolve. It'd be interesting to see what happens. I'm really excited and keen on this because there's lots of work still to be done in terms of getting this off the ground. The regulations for this alone are 800 pages long, so it gives you some idea of what everyone's up against. There's 16 different agencies involved here as well. You've got the Maritime and Coast Guard Agency, you've got the Nuclear Fuels Agency, you've got the Health and Safety Executive, you've got all sorts of different organisations who have to tick this all off and make sure that it all goes through, and then it still has to go through Parliament and the UK government. Meanwhile, Sweden, Norway and Iceland seem to be roaring ahead with their space programme. They seem to have got through some of the legislatory hurdles a lot quicker than the UK. And then you've got Australia as well. And Australia have got a really burgeoning space industry. So the number of launch options that are going to be available for UK companies who are already sending payloads over to JAXA, Roscosmos, for example, in Russia, most notably SpaceX, because SpaceX's costs are lower than anyone pretty much else can compete with because of the reusability of the rocket. So it's going to be really interesting to watch and make sure that this kind of does pan out to be something that's not only technically viable, scientifically viable, but economically viable as well. The other interesting thing with the Shetland site is there's a conference happening later this week, which has been organised by the Shetland Space Centre, but also involving DASA, which is the UK's defence arm. So clearly, you've got a major defence prime in LM. You've got DASA involved in this. So watch this space as to what kind of payloads are going up from there. Obviously, there will be scientific, there will be academic payloads, but it's kind of watch this space and see what's happening. Really interesting story, one that I've been following for quite some time. I don't know if you've got any thoughts on this, Terry, but it's going to be an interesting few years, I think.
Absolutely. The good thing about it is basically it's as far north you can go in UK territory. It's on Lambda Ness on the island of Unst, which is the most northerly of the Shetland Islands. So that's as far as you go in terms of northernness in UK land. You have nothing ahead of you except open North Atlantic Ocean. The weather, a bit variable. Sometimes I'm sure the wind will be a bit strong for doing a launch, but most of these launches are not absolutely time critical. You're not in a launch window to try and get a spacecraft to Mars or something like that. So if you're delayed for a couple of days, it's not a big issue. One other thing I would be looking forward to from a purely personal point of view, I don't know just how close you'll be able to get to the site to actually view a launch, but when you're up there, an absolutely fantastic place to watch out for the aurora at night. So if the sun decides to get a bit more active and produce some nice aurorae, you could go up there for a launch. You'd probably be a couple of miles away for safety reasons, but when you're there, you're at the best place within the UK to see the aurora. So I always like that as an added bonus.
Yeah, the capitalization on the tourism side, I think, is going to be really, really interesting. As Terry was saying, I think having that capability of watching aurora, having some really good dark skies as well. I'm hoping that the people involved with the Shetland Space Centre are going to be focusing on that as a kind of whole holistic offering for the launches. Because watching a rocket launch is fun. If you've ever been to Cape Canaveral, they are a lot of fun. These aren't going to be the same. These are going to be very similar to what Rocket Labs are doing down in New Zealand. So, but Peter Beck in New Zealand has done a fantastic job in terms of the PR. So I think it's going to be more one that people watch on live streams, on video screens, etc., rather than going up there. But if you are up there, yeah, it's going to be fun. And fingers crossed, within about 2.5 years, hopefully we'll start to see launches if it all goes to plan. So moving on to a little bit further out. Another Lockheed story. They built this spacecraft. So this is Osiris-Rex. It's been out kind of going towards the asteroid Bennu for quite some time and spent the last few years kind of orbiting around it. Now, orbital dynamics is hard enough as it is, but orbital dynamics, when you're looking at orbiting an asteroid that's only a few hundred meters across, that has almost no gravity, this is off the scale complex. This is incredible in terms of orbital dynamics and what they've been doing here. The gravitational field on this asteroid is so low that literally they were watching rocks fly off the side as it was rotating. It's only got about a 4.5-5 hour rotation period. So Osiris-Rex, we talked about this briefly in the last show, was basically going to touch down on the surface of Bennu and use this sample grab tag, they called it, to kind of tap and go. And Terry, it got more than it bargained for, didn't it?
It did indeed. It was too successful in a way. but you can't be too successful strictly. The way they did it was basically they put an arm down from the spacecraft to touch the surface, and then they let out a blast of nitrogen gas, a purely neutral, non-organic gas, to stir up the material from the surface. And as you say, the gravity is so low that a blast of gas would actually shift quite a large rock off the surface. But they chose an area where the particles were relatively small. So the procedure was basically the blast of gas would stir up the material, which would go into the capture canister, if you like, not quite a canister, but at the end of the arm, and it would collect a variety of size of particles from small dust, basically up to small pebble particles. And it worked brilliantly, all done remotely, basically, because there's a roughly 30, I think it was 36 then, it's now 37-minute time delay between a signal coming back from Osiris-Rex to Earth and then a signal being sent from Earth back to Osiris-Rex. So the whole thing was pre-programmed with a sort of its own artificial intelligence to interpret what it saw and where it was going, how close it got, and what maneuvers had to make. All worked perfectly. The nitrogen gas blasted, the material was caught, and the spacecraft Osiris-Rex backed away. They then had to try and assess how much material they'd actually got. Their minimum target was 2 ounces, or about 60 grams. And what they found was that they'd been so successful that the capture part of it was full. The little lid, if you like, that was over the top of it wouldn't close properly, because there were so many fairly large pieces of material there that the lid literally wouldn't close. Now, how do you assess how much material you've got? Well, they didn't want to send up a pair of scales on the spacecraft, which wouldn't work in that sort of gravity anyway. So there were two ways. They were going to look at it with video imaging, and they were going to rotate the spacecraft, and by the measurement of the angular momentum that it took to produce a certain rotation period, they could assess how much extra mass had been acquired by the spacecraft. So this is rocket science, literally. But what they found was that the little particles were actually escaping from the capture part of the thing. I've forgotten the name, it's just got out of my head at the moment. But anyway, because the lid wasn't closed properly, the little particles were escaping. So they're not going to now spin the spacecraft. They're going to actually put what they've got directly into the return capsule. And Nick, you can say a bit more about that.
Well, if you've seen some of the videos of this kind of tag maneuver, it is amazing. I mean, literally, NASA were broadcasting this within a few hours of it happening, which is fantastic. And there's a pointer for ESA with the Rosetta mission. Don't ever do what you did with the camera data again, please, because waiting a year or whatever, it's not going to fly with anyone. But amazing watching NASA do this. The really amazing thing, going back to the orbital dynamics on this, this was at about 300 million kilometers away. As Terry was saying, you got a 36-minute kind of light travel time to get your signal back and forward. So it's completely autonomous. So this spacecraft was using a technique basically generating what's called voxels, which is kind of like your kids might do with Minecraft and stuff like that. It's kind of a representation in 3D space that the imaging system on it could detect what was there. Now, when they got there, the idea was that they were going to touch down in what they hoped would be a relatively smooth plain area and knock up some dust and collect it. They didn't find any, so they had to kind of reprogram the spacecraft to get around this. The accuracy of this at 300 million kilometers, and don't forget this asteroid is rotating about 10 centimeters per second, right? They got it down to 0.7 of a meter accuracy in terms of the landing site. It was literally insane. My hat absolutely tips to Dante Loretta and the whole team on Osiris-Rex who put this together, because it's off the scale. They managed to collect, from what the initial data shown, around about 400 grams of material, which is the highest return since Apollo of any kind of sample return mission. It's way more than they hoped. 60 grams is what they were hoping for, but they reckon about 400 grams of this. It's now going to come back to Earth by 2023. It's going to enter Earth's atmosphere, hopefully then be safely recovered, taken to a lab, and then between JAXA, who've got obviously their own mission with Hayabusa, and NASA and various other teams around the world, some sample material will be sent out and analysed, and hopefully it'll give us some really good insights into the earliest days of the solar system. But this mission's not over yet. It's just the gift that keeps on giving. I love it. There's not much more you can say. It's just brilliant.
The important thing about this particular asteroid, Bennu, we have already got samples back from Itokawa, from the Hayabusa spacecraft, and there's another one on its way back to Earth, actually due to come back to Earth on December 6th of this year from Ryugu, from the Hayabusa 2 spacecraft. But this particular asteroid is fascinating. For a start, it's classified as a near-Earth asteroid, and it doesn't come all that near to us, but it's a very primitive asteroid. It's a type 2 carbonaceous chondrite, and they think that is basically the sort of material that was there right from the birth of the solar system. And interestingly, they may also be little bits of the asteroid Vesta on it, because there have been collisions involving Vesta. So you may get two for the price of one with this. So fascinating. Most of the material that we can study now on Earth, whether it comes via meteorites or looking at the Earth itself or the Moon, has been processed by various either weathering or geological processes over time. This is taking us right back to the very early first few, maybe 50, 100 million years of the solar system. Absolutely important to be able to study that properly.
And plunging in as it did, again, going back to the videos, they went subsurface here. So obviously you're going to get some kind of solar irradiation and weathering on the surface rocks, but the subsurface ones potentially haven't been touched for about 4 billion years. So, and the beautiful thing about carbonaceous chondrites is not only have you got this primitive material, it was the kind of foundation point of our solar system, you also in some of them get pre-solar grains. So what happened before our solar system was formed, where you got this shock wave from a potential nearby supernova that collapsed the gas cloud that then went on to form the sun and everything else, that's in there. That could potentially be in there. So this is going to be amazing. Definitely one to watch. Definitely. Moving on to our next story. Another one to watch. So a few weeks ago, massive press release, handled very, very well by the Royal Astronomical Society, really extremely well. There was all sorts of shenanigans going on with the International Astronomical Union and various people complaining about it, etc. But really did a good job. It was handled well by the press, etc. About the potential discovery of phosphine in the atmosphere of Venus. Now, phosphine is one of these possible biosignatures. So a team using the ALMA telescope, based out of Cardiff University, Imperial College, various other UK universities and some in the US as well, had done some studies, and it looked like they detected phosphine in the high atmosphere of Venus. And we talked about this during the last show. What's now happened, however, is that other people have gone and scrutinized this data, and the computer says, no, doesn't it, Terry?
It could either be a spurious signal, or it could be basically a signal of something different altogether, sulfur dioxide, or the signal is basically just creeping above the noise level. One of the things about Venus is it comes very close to us, very bright. And there's a huge amount of noise in Igni signal that you get from Venus, particularly with the really big instruments that they were using, like the James Clerk Maxwell Telescope in Hawaii and ALMA in Chile. Very, very powerful instruments used mainly to detect the faintest possible signals from the distant parts of the universe. But here they were getting something for the amount of signal coming in was very, very high, very, very noisy. And it is quite easy to be misled whenever you have an awful lot of noise in the signal. So that's one possibility. Other people have simply looked at the data that they had again and said, no, we don't see any signal there. They also looked at archival data going way back to the 1970s from Pioneer Venus. Now, it wasn't designed to look specifically for phosphine, but it had nevertheless surveyed the atmosphere of Venus. They couldn't find anything there. So you don't know. I presume that the team that did this, led by Jane Graves, were very, very careful in eliminating all possibilities. Whoever refereed the paper will probably have looked at all these possibilities too. But this is the way science works. You think you've made a discovery, you announce your results, you make your data available, and then other people look at that data and they also try and replicate your actual observation, either using different telescopes or similar telescopes. And if they don't find it, then it remains unproven. If they do find it independently by using other means, then it becomes more or less confirmed. That's the way science works. There have been many false dawns, if you like, of discoveries which have proved to be basically not true, not backed up by other data. That's the way science works. It's no bad reflection on Jane Greaves or any of her team that this turns out not to be what they thought it was.
Well, that's the thing. This team at the University of Leiden, basically, they reanalyzed the ALMA data. They said there's no statistical evidence of any phosphine detection. But as Terry said, this is how science works. You only have to go back to some of the greats, like even Albert Einstein fudged the cosmological constant, basically, which he said was the greatest mistake of his life when he was working on theory of relativity, etc., which turned out to be his biggest mistake, because Hubble then proved that the universe was expanding. So it's one of those things that, you know, if it turns out that it isn't phosphine, that it's something else, great, we've learned something new about science. The downside with this, I guess, is that the public perception of science can sometimes get a bit tarnished. If the public don't understand how the scientific method works, then essentially if they see, oh, a big news story, and then, oh, it's actually not that, they may kind of almost get the cry wolf syndrome kind of effect happening, where, oh, another big news story, and oh, it's not really that in the end. So all credit, as I said, to the Royal Astronomical Society, to Jane Greaves and her team. They've opened this up. They've said, we're not sure, please prove us right or wrong. And by doing that, I think they've taken the right approach. And if it is right, fantastic, you know, potentially we'll send more spacecraft there. If it isn't, no great loss, and you know, it's still great science happening from Venus, and there's still missions going to go back there. Peter Beck at Rocket Labs mentioned earlier, they're still planning on sending a mission to Venus, so hopefully we'll get more and more and better data, and hopefully one day a return to the surface, because that needs to happen, in my opinion. Venus is really interesting. Everything's going to Mars. Let's get back to Venus. It's incredibly difficult because of the atmospheric pressure, because of the atmosphere being acidic and the acid rain and all sorts of different reasons, and the temperature, you know, hotter than 200 degrees hotter than an oven. But it needs to be re-explored. We've not done it since the Russian Venera spacecraft. So it's one of those things we definitely need to go back to Venus. And my hat tips to all the scientists working on this. It's definitely really, really interesting. On to our last story, which is one that we cover quite regularly. It's a thing of beauty. I've got to be honest. My continued love-hate relationship with Elon Musk and SpaceX does continue. Starlink, there's been more evidence this week come out of the failure rates on Starlink, now showing at around about 3%, which if you put at 42,000 of them, you're looking at well over 1,000 dead and defunct satellites just rolling around in space and basically forming a massive collision problem. So Starlink aside, and the fact that he's the initial costs of the Starlink system, from what we've heard from CNBC today, are looking like a $499 setup cost and then $99 a month. So the whole, oh, it's for the good of people in Africa, etc., and for remote communities, seems like a little bit, you know, of, yeah, maybe a bit of artistic license being used there. But you have to say that what he's doing with Starship and the Falcons, etc., is remarkable. And now we have SN8. So all the other SNs we've talked about, the grain silo launches in the past, SN8 now looks like a rocket. So the Boca Chica site down in Texas, they're building something that looks like a rocket. That's it, kind of getting ready to fly. And they're thinking of putting this up to 15 kilometers on a test hop. That is going to be something else to see. Nothing this large since the Falcon Heavy has launched since 1973-4, kind of with the end of Skylab, with the last Saturn V mission. Watching this thing take off when it eventually does is going to be literally earth-shattering. I don't know if you've got any thoughts on the design of the rocket, Terry. I know it's kind of a bit Tintin, but
yeah,
it's amazing.
It looks like a rocket, as you say. Before, it just looked like a grain silo. You get a rough idea of the scale there by looking at the two people on either side of the main cylinder there, and the little arms going out from the cranes. But this is actually just the top stage of what will eventually be launched on top of the Super Heavy. I'm always slightly puzzled by how quickly he's developing this when he hasn't even got the prototype of the rocket that's going to put that up into space yet. It's a bit like designing a bullet when you haven't got the gun yet ready to fire it. But I have faith in him. He's been doing so well with everything so far. But This thing has now got 3 Raptor engines in it. The first firing only had 1. The final stage of this will actually have 6 of those Raptor engines, and that will be an absolutely tremendous amount of thrust and very efficient engines. But the Super Heavy, which will launch that will be basically sitting on top of the Super Heavy. That's going to have up to 30 of those Raptor engines. So that will be, as you say, literally earth-shattering. You don't want to be within about 5 miles of that, or your fillings will fall out when something like that takes off. So yeah, I agree with you totally about the bad side of Starlink and the pollution of the sky, which is now affecting not only optical astronomy, but radio astronomy as well. But full credit to him for what he's doing with this. And it's all part of the goal to get the Artemis project on the moon, and then certainly as far as Musk is concerned, to eventually get humans to Mars. So more power to his elbow on this side of it.
Well, that's the thing, the cost as well. You compare this to the Boeing SLS and what NASA are doing with SLS and Artemis. The cost on that is astonishing. It's in the tens of billions now and massively behind. And yeah, that's going to be huge. I mean, the SLS full stack, when it goes up, is going to be slightly larger than the Saturn V. But as Terry was saying, the sheer number of Raptors, the Saturn V was powered by 5 F1 engines. I mean, these things were generating the energy output of the entire United Kingdom for the first 146 seconds of flight. I mean, it was generating something like 66 gigawatts of energy. It's an astonishingly powerful rocket, beautiful and elegant as well. Everyone loves the Saturn V. With this, putting 30 separate Raptors, and then on the second stage, more Raptors, all of which you've got to be able to gimbal and control. I mean, gimbaling is this kind of movement where the engines have to basically move to keep the spacecraft on its trajectory, is going to be a technical achievement tour de force in its own right. If you've seen the space shuttle launch, you'll know that you have to be several miles away, and you can feel that in your stomach. Anyone who remembers the Saturn V launch, I've got a few friends who were at Apollo 15 and various other launches, said it literally is earth-shattering. So this, who knows? I mean, you're going to have to be some distance away to kind of even tolerate what this thing's going to generate when it goes up. And they've still got to test it, don't forget.
Yeah.
So this is the other problem. When you're doing static testing, you've got to do it in a location. So the old Saturn V, you at Michoud and the Missouri test sites, etc., and then they kind of take the spacecraft up to the Cape, either on barges or various components on aircraft, etc. How are they going to test this? Where are they going to test this? I don't know. I mean, I've got friends who live in this part of Texas who've watched some of the previous launches, and they've been able to hear those launches from their houses, which are like tens of miles away, and see the rocket going up. So where you test 30 simultaneous Raptors, and they're going to have to, good luck on that one. It's going to be fun, but a heck of a thing to see. And I just hope in the next few years we all get to see it. This thing's going to be huge. I mean, literally enormous. You look at the rockets we were talking about, the site up at Sutherland and Shetland, those are going to be like 30 to 40 meters tall. The average Falcon 9 is almost double the height of that, or potentially double the height of that, and that's just the Falcon 9. Falcon Heavy, significantly bigger, and that was 27 engines firing all at once. And again, they didn't think that was going to work, but it worked flawlessly first time. Put a Tesla on a nice Mars trajectory orbit. This is a whole other level. So definitely one to watch. Any other comments, Terry?
No, as I say, I'd love to be there to see it and hear and feel a launch, because you feel it as well as seeing it and hearing it. So whether they will have any sort of a public viewing facility for this, I don't know, but they'll be missing out. And of course, Musk is sort of brilliant on the PR aspect. I mean, putting the wee Starman inside his Tesla off to Mars was an absolutely brilliant PR aspect. So I'm sure he'll be allowing people to come and observe this sort of thing from a safe distance, and I'd really love to do that.
If you've not seen it, if you've got access to Disney Plus, I'm not giving a plug to Disney Plus here, other channels are available, but there's a really great documentary on SpaceX and the trip to Mars. And yeah, he is incredible with his PR when he's talking to his kids and he's saying, look at that, kids, you've driven in that Tesla. It's that kind of thing that money can't buy things like that. It's amazing. And the views from the Tesla when it went up, and the kind of don't panic on the dashboard, he knows how to do PR better than anybody in the world. So yeah. Good luck to him. Good luck, obviously, as well to Jeff Bezos and everyone else who's doing this stuff. But this is going to be the one to watch, I think. And finally, what to look out for this week. So I'll let Terry take away on this one. I've been looking at Clavius. I had a look at Clavius last night. I was doing some imaging with my own observatory in the back garden up in Cepheus and some of the nebula there. It's a beautiful nebula. Cygnus is still really good at the moment. But any thoughts, Terry?
Yeah, I'm going to start with Clavius because it's so much in the news at the moment. It's not the biggest crater on the moon, it's the second biggest, but it is the biggest of the well-formed craters. The other one, Deslandres, is just slightly bigger, but it's almost ruined. The walls are almost collapsed. It's very hard to make out. Clavius really looks at a crater, and it's huge. It's 225 kilometers in diameter. I'm in Northern Ireland. You could put the whole of Northern Ireland inside that crater. And the amazing thing about it as well, if you look at it through a telescope, it's got two sizable craters on the rim of the crater. Each one is sort of punched a big depression in the rim of the crater. They would be major craters on their own. But when you look at them compared with Clavius itself, they look tiny. But the rather really fascinating thing about Clavius is that from one of those craters, there's an arc of other craters that go round in a curve across the floor of Clavius itself. And it's an almost perfect arc. And the interesting thing is that the diameter of the craters just decreases from the big one on the rim right down to the last one. I think it's either 5 or 6 in a row. Absolutely unmistakable. It's near the south pole of the moon. You can see it tonight. It's clear. If you can't identify it first time, look for a very, very bright crater called Tycho near the southern part of the moon with bright rays emanating from it. It's almost unmistakable. Quite sizable, though nowhere big as Clavius. And if you go from Tycho then towards the nearest part of what we call the terminator, which is the edge of the moon where the sun is just shining, Clavius is just about there, absolutely unmistakable. So if you've got any telescope or even a good pair of binoculars, go out and have a look for that and think just how big it is. And what I always think is, what size of an object hit the moon to make a crater 225 kilometers across? Absolutely mind-blowing. Now,
because you've got like Arizona meteor. Sorry, Terry, you've got the Arizona meteor crater, which is the famous one that everyone knows, and that's only a mile across.
Yeah, I know. Now, one of my pet subjects, and I could talk about this all night, you'll hear on the media, read 31st October, blue moon. It's not going to be a blue moon. It just happens to be the second full moon that occurs in the month of October, which happens every couple of years or so. The average moon period from one new moon or one full moon to the next is 29.5 days. Most of the months have either 30 or 31 days. So automatically, every so often, you're going to get 2 full moons in the same month. And the media have really latched onto this, and there's other ways of defining a full moon. The moon is not going to be blue at all. It's not going to be any particular color. It just so happens that there's going to be 2 full moons in October. And of course, this one falling on Halloween, everybody will be attaching sort of spooky, ghosty type attributes to it. It'll just be an ordinary full moon. Go and have a look at it, but it certainly won't be blue. Looking at the other objects that we've already talked about, Mars has just passed opposition. It's still very bright, beautiful ruddy orange color. And if you go out and look at it tonight, it's not too far away from the moon, just a bit to the left of the moon as you look at the moon. And Venus, which we also talked about, visible in the early morning twilight. Very, very bright, brighter even than Mars. It's slowly slipping in towards the sun, so it's getting harder and harder to spot in a dark sky all the time. And going back to something that we didn't talk about particularly, the sun, although I did mention it in relation to aurorae. The sun is going through a very deep minimum with very, very little sunspot activity. But at the moment, a relatively big complex sunspot has just appeared and formed. Don't look at the sun directly if you don't know what you're doing. Don't look at the sun through any sort of an optical instrument. Contact your local astronomy club or do a search on the internet for how to observe the sun by using a telescope, by projecting the image onto a piece of paper. You don't look at the sun through a telescope or binoculars. So there's a sunspot. It's getting more and more active. It may possibly send out a coronal mass ejection, which may reach the Earth and may possibly cause aurorae. So watch any of the space.com or any of the Aurora alert websites and see we may possibly get an Aurora later this week. But that's what to look for at the moment.
Going back to the sun, it's a kind of something I like looking at a lot. I've got a range of specialist telescopes, as Terry was saying. Never bought a telescope or a binocular directly at the sun. There are telescopes you can buy called hydrogen alpha telescopes or calcium kaline telescopes. They're quite expensive, but they enable you to look at the sun in different frequencies of light. Looking at the sun over the last few days, there's been some spectacular prominences. So these are kind of like the fires on the edge of the sun, which you can see these like gigantic kind of solar eruptions on the side. There was one today that was literally about 80,000 miles across. It was just, sorry, 800, was it 80,000 miles across. It was just huge. And that was a tiddler. I mean, some of these prominences, when you see them, they are the distance from the Earth to the moon in terms of like angular size on the edge of the sun. Really fantastic. So if you get a chance with the local astronomical society, if they've got what's called a H alpha telescope or a CAC telescope, CAK, calcium kaline, that typically needs a camera because your eyes aren't really attuned to ultraviolet end of the spectrum. Well worth seeing. If you don't have access to that, there's a website called BASS 2000. If you type in BASS 2000 Solar Survey Archive, you can see all of this data literally real time from a whole range of different telescopes, and it's a great way to decide if you're going to go out and have a look at the sun with specialist instruments of your own. So definitely one to look out for. The other thing is Orion's rising. The Pleiades in Taurus is kind of one of my summer's over kind of pointers, as it were. They're really good at the moment if you go about midnight, and if you've got a Subaru car, that's the symbol on the front of your car, the Seven Sisters. Well worth a look at. But if you can wait up until like 2-3 in the morning, glorious views of Orion at the moment in dark skies. Wait until the moon's kind of more gone than it is right now. It's, as Terry said, we're approaching a full moon. It tends to wash out a lot of the fainter stuff in the sky. When there's no moon in the sky and Orion's up, it's absolutely spectacular to look at. Even with binoculars, looking at the Orion Nebula is really amazing. So they're the things I'd definitely recommend to look out for in the coming
just in case anybody has a Subaru car, if you go and count the stars, there are only 6. Whether that tells you that the Japanese are slightly less acute in their vision, I don't know. They're called the Seven Sisters because in the dark sky, most people can see 7 with the naked eye. Some can only see 6 or 5. If you've got very good eyesight, you can see about a dozen. When I was young and looking in the very best of conditions and knowing where to look, my record is, I think, 13. Somebody else has seen about 16, but that's from the top of a high mountain in the clear desert skies of Arizona. So it's a good way of testing your eyesight and the local conditions. See how many Pleiades you can see. 6 or 7's fine.
Cool. We've overrun, but thanks again to amazing team at the Space Store. Once all this pandemic stuff is over, hopefully in the new year, well worth a visit. It's quite near to the Harwell Space Cluster in Oxfordshire, where they're based. A little town called Didcot. Really fascinating. Great experience you can get there. Huge thank you as ever to them for hosting us and supporting us with this regular roundup. And I know we've overrun a little bit, but just hand back to Latch and just say thank you.
Yep, thank you.
Great. Thank you so much, Nick and Terry. It's been incredible having you tonight. I hope everyone who tuned in enjoyed tonight's roundup. If you haven't caught up with all of our other previous roundups, you can do on our channel. We've created a special playlist for you, so go check that out. And don't forget, in 2 weeks' time, 10th November, we'll be back, same time, same place. But before then, this Thursday, we have another Space Store Live Thursday night talk for you. It's another interesting one. We're going to be talking with Claudia Blagu about digital forests. Sorry. So make sure you tune in for that one, Space Door Live on our YouTube channel, and we'll see you guys then. Thank you, Nick and Terry. I hope you guys have a good evening, and thank you for tuning in.
Adios, amigos.
Bye, everybody.
Good night.
Bye.
Bye.
Yeah.